Welcome to this new video. This is the part 2 video of empirical formula and molecular formula. I told you that we are going to look at this subtopic under empirical formula and molecular formula. Determination of empirical and molecular formula from percentage composition by mass. Determination of empirical formula and molecular formula from percentage composition by mass. Let us look at the first question. And this one we are going to solve question in this video. Is solving of questions. We solve question. I will teach you how to solve this question. What really matters is the first video. To know the relationship between empirical formula and molecular formula, which I've given you. And in this next video, it's all about solving. It's all about solving. Let us look at this first question from your JUPEB. We are, what is the chemical formula of a compound? What is the chemical formula of a compound with 11.11% of hydrogen and 88.89% of oxygen? Solution to question 1. Solution to what? Question 1. How can we get this? The first thing you have to do, you have to get what? Atomic weight ratio. Atomic weight ratio of each of these elements in that compound. You have to calculate the atomic weight ratio or mole ratio of each of these elements, hydrogen and oxygen, in that unknown compound. You have to calculate atomic weight ratio, which is also known as what? Mole ratio, which I can also call what? Percentage by mass what? Ratio, which I can also call what? Percentage by mass ratio of each of these two elements, hydrogen and oxygen, in that unknown compound. How can I do that? And we have hydrogen, I have oxygen. This is the element. I have elements. They are percentage by composition. Percentage composition. They are percentage composition by mass. By mass is given as for hydrogen is what? 11.11. For hydrogen is 11.11. For oxygen is what? 88.89%. Take note of that. And take note, addition of the two must give you 100%. If there are 3 elements, 3 atoms in that compound, and you have their what? Percentage composition by mass. Addition of their percentage composition by mass must give you what? 100. If there are 4 elements in a compound, their percentage by mass composition must give you what? 100. Their percentage composition by mass must give you what? 100. The addition of percentage composition by mass must give you what? 100. If you add 11.11 and what? 88.89, you must get 100. Take note. Then what is the next thing? Don't forget, we have atomic weight. The atomic weight, mass number of hydrogen to be 1, mass number of oxygen to be what? 16. What will I do? I will get what? Via what? Mole ratio, atomic mass ratio, or percentage composition by mass what? Ratio. I call it percentage composition by mass ratio, or you can call it what? Mole ratio, or you can call it atomic weight ratio. How do we do this? That means this percentage composition by mass, which is 11.11, divided by what? The mass number of hydrogen, which is 1. Oxygen, the percentage composition by mass of oxygen, 88.89, divided by what? Mass number of oxygen, which is what? 16. Then from here, what do we have? 11.11 divided by 1 will give you what? 11.11. 88.89 divided by 16 will give you 5.55. Then what do we do? Get what? Simplest ratio. How do we do the simplest ratio? Divide by the smallest what? Number. Divide by the smallest number. Here we have 2 numbers. That means divide by the smaller one. If there are 3, divide by the smallest. If there are 4, divide by the smallest. In this case, divide by the what? The smaller one. That is what? Simplest ratio. This one divided by what? 5.55 over 5.55. What do we have? From here, the 1.11 divided by 5.55, we have 1. 5.55 divided by 5.55, we have 1. That is empirical formula of that unknown compound for hydrogen is what? This one, I'm sorry. The 1.11 divided by 5.55 is 2. That means it can go in 2 places. Please, you can go in 2 places. The 1.11 divided by 5.55. That means you have 5.55 times 2. You have what? You have 0, you have what? 10, 1, then you have 1, 1.10. Please, I'm sorry for that. Please. That means you have 1.11 divided by 5.55, you have 2. This one, you have 1. Then for empirical formula, that means you have 2. Hydrogen is what? 2. Oxygen is what? 1. Therefore, the empirical formula is what? H2O. And don't forget, I told you in the first video that empirical formula and molecular formula can be the same. When what? You cannot simplify what? That molecule any further. Or when what? N, which is the ratio of what? Molecular formula to what? Empirical formula is 1. Look at this. The ratio between hydrogen and what? Oxygen. What do they have in common? Is what? 1. Therefore, this empirical formula is the same thing as what? Molecular formula. And the question says, what is the chemical compound? That is, what is the molecular formula? The actual formula. Therefore, molecular formula equal to what? H2O, which is the actual chemical formula of that compound. H2O. Please take note of that. Let's go to the second question. You can pause the video, look at it, write it out, and let's go to the second question. I believe you've done this. Number 2. Second question. Solution to number 2. Solution to second question. Solution to what? Second question. The second question says, determine empirical formula and molecular formula of an oxide of nitrogen. Oxide of nitrogen. That means the compound is what? Oxide of nitrogen. We have X, we have Y. That means the compound contains nitrogen and oxide. I told you, when 2 elements, there's a video that will be released. When you have 2 elements, binary compound, 2 elements combining together to form a compound, binary compound. The last element you carry what? IDE. Then this one says what? Nitrogen, oxide of what? Nitrogen. That means combination of nitrogen and what? Oxygen. Oxide of nitrogen, combination of nitrogen and oxygen. That means oxygen is the last element. Why? Because it carries what? IDE. That means with this one, I should know that there are just 2 elements in that compound, which are nitrogen and what? Oxygen. Binary compound, where you have what? 2 elements combining to form a compound. The last element carries IDE. Because I see oxide of nitrogen, that means that compound contains nitrogen and what? Oxygen. That means binary compound, IDE. The last element is oxygen. And they want you to get the empirical formula and molecular formula of nitrogen oxide. Let's look at the question. That is, this is NSOY. They now say nitrogen containing 30%. Nitrogen containing 30%. If nitrogen is 30%, I told you percentage composition by mass. When you sum it up, must be what? 100. Isn't it? I told you. If you have 2 elements, and you have percentage composition by mass of 1 element in a compound to be 40. What will be the percentage composition of the second element in that compound? It will be 60. The sum must be 100. If there are 3 elements in a compound, if percentage composition of the first one is 30%, percentage composition of the second one is 20%, what will be the percentage composition of the third one? It will be 50%, because addition must be what? 100. Then in this one, I know that the compound contains two elements, which are hydrogen and what? Oxygen. And the same percentage composition of hydrogen is 30. Therefore, percentage composition of oxygen will what? 70%. Then, how will I do? This date the same format. I have my element, which are what? Nitrogen and what? Oxygen. Then, I have what? Percentage composition. Percentage composition by mass. By mass. That means percentage composition by mass of nitrogen is 30%. Oxygen is what? 71%. Then from there, what will I have? Atomic mass ratio or percentage composition what? Ratio. Or percentage composition by mass what? Ratio. Atomic weight ratio. Atomic weight ratio. Or percentage composition by mass ratio or mole ratio. I have this. That means this one, 30 divided by the mass number. You must know that this mass number of nitrogen is given as 14. Oxygen is given as what? 16. Take note of that. You have to know 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 that. Percentage composition by mass 30%. Oxygen is what? 70%. Then atomic weight ratio. That is 30% divided by what? Mass number of nitrogen, which is 14. 70% divided by mass number of oxygen, which is what? 16. Which is what? 16. Then what will you add? What will you add? You have for this one, 30 divided by 16, you have 2.143. Then 70 divided by 14, you have 2.143. This one should give you 4.32, we have 70 divided by 16, well, 4.175, something like that, 4.175. Then what will you do? Simplest ratio. Simplest. Divide by what? The smaller value. Divide by the what? Smaller value. Divide by the smaller value. Divide by the smaller value. So you have 4. Then you have 4. Okay, 3. Yeah, you have 3. Then divide by the what? Smaller value. That is divided by the smaller value. Between these two, which one is what? Smaller value? That is 2.143. That is divided by 2.143. Divided by 2.143. Divided by 2.143. So that you can understand. Okay, divide by the smallest by the smallest, simplest ratio. Divide by the smallest value. But in these two cases, divide by the smaller value. This one will give you 1 over 2.143. You have 2.04. 2.04. You have something like this, 2.04. Then from here, approximate this one is not up to what? 1. That means we have 2 points. Therefore, in this case, we have empirical formula will be equal to nitrogen. How many do we have? 1. Nitrogen is 1. The oxygen, we have what? O2. That means empirical formula is what? NO2. That is empirical formula. And the second question says calculate what? Molecular formula. Calculate molecular formula. The second one says calculate molecular formula. This question is from your JUPEB. Calculate molecular formula. Calculate molecular formula. Calculate molecular formula. When the relative molecular mass is given as what? 92. Relative molecular mass is given as 92. That means relative molecular mass is given as 92. Relative molecular mass is given as 92 gram per mole. Calculate the molecular formula. Don't forget, what is the formula that connects molecular formula and empirical formula? I told you, molecular formula equal to N into empirical formula. Therefore, molecular formula equal to N into empirical formula is what? NO2. That means NO2. From here, relative molecular mass is given as what? 92. I will change this molecular formula to what? 92. I have 92 equal to N into mass number of nitrogen is 14. I have 14 plus mass number of oxygen is what? 16. That is 16. How many oxygen? 2 times 2. Therefore, here I have 92 equal to N into 14 plus this one give you 32. 32 plus 14 will give you 46. I have 92 equal to N into 46. Divide both sides by 46 over 46 over 46. This one cancel, you have what? N equal to this one divided by this 2. Therefore, N equal to 2. N is 2. Since you've gotten N to be 2, then what will be the molecular formula? Molecular formula. That means these two, that molecular formula equal to 2 into NO2. Therefore, molecular formula equal to 2 times 1 N2. 2 times 2, O4. Take note of this. That's your answer. N2O4. That's the molecular formula. Please write it down. You can pause the video and write it down. You can pause the video and write it down. Please pause the video and write it down. Let's go to the next question. The next question, number 3. This is Unilab First In-Course Exam, JUPEB. Unilab First In-Course Exam, JUPEB. Unilab First In-Course Exam, JUPEB. Let's look at it. Let me rub it. Let me rub it. Let me rub it. Or let me rub out. Let me rub off. 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 Let me rub. Let me. Hey, show you the one me. Show you the one nobody said. Okay, let's look at this. Solution. Question 3. Solution to question 3. Solution to question 3. Solution to question 3. What is the question? A substance has the following composition by mass. 60.8% of sodium, 28.60% of boron, and 10.60% of hydrogen. What is the empirical formula? We are given option. Let's look at it the same way. We have element. Element, which are the first one, we have sodium, we have boron, we have hydrogen. Percentage composition by mass. Percentage composition by mass of each of the atoms in the compound is given 60.8%, 28.60%, and 10.60% is given. Is given. I told you, addition of everything must give you what? 100. Addition of everything must give you what? 100%. Addition must give you 100%. Then let's move from here. If you have to get 100%. Let's move. Please, let's move. From here, what will you do? Calculate atomic weight ratio. Atomic weight what? Ratio. Atomic weight ratio. Atomic weight ratio. Or percentage composition by mass ratio. Or mole ratio. Calculate atomic weight ratio or percentage composition by mass ratio or mole ratio. You can call it that. Atomic weight ratio. This one is 60.8. The mass number of sodium is given as 11. You should know that. Sodium is 11. Boron, sodium is 23, I'm sorry. Boron is what? 11. The hydrogen is 1. Take note. Sodium is 23. Boron is 11. Hydrogen is 1. There's a shortcut to know atomic weight, mass number of elements without giving you. I have shortcut. From 1 to 20, I have shortcut. If they are even number, multiply by 2. Odd number, multiply by 2, add 1. Except of boron. Except of boron. Except of beryllium, nitrogen, chlorine. Those ones are special case. Except of what? Beryllium, nitrogen, and what? Chlorine. They are special case. But for any other word element from 1 to 20, if they are odd number, multiply by 2. If they are even number, multiply by 2. If they are even number, rather, multiply by 2. If they are odd number, multiply by 2. Then add 1. Please, multiply by 2, add 1. Multiply by 2, add 1. Sodium is what? 23. Boron is 11. Hydrogen is what? 1. Take note. To know atomic mass or mass number or atomic weight of what element, if you are not given, from 1 to 20, we have exceptional cases. Beryllium, nitrogen, and chlorine, they are exceptional. If you have odd number, multiply by 2, add 1. If they are even number, just multiply by 2. For example, sodium. Atomic number of sodium is 11. Atomic number of sodium is 11. For you to get the what? Atomic mass. That means this one is an odd number. 11 times 2 plus 1. That 11 times 2 will give you 22 plus 1. That is 23. For example, when you have carbon, carbon is 6. Atomic number is 6. Just multiply the atomic number by 2. Oxygen, atomic number is 8. Mod 8 times 2, you have what? 16. Take note. Take note. Phosphorus is 15. Atomic number is 15. It's an odd number. Atomic number is 15, odd number. 15 times 2 plus 1, that means 31. Listen, that's how to do it. For the first 20th element, I have from 20th to 30th, I have from 31 to, but for the first 20th element, with the exception of what? Beryllium, nitrogen, and what? Chlorine. These ones are exceptional cases. You understand? For other one from 1 to 20, atomic number 1 to 20, if the atomic number is what? Even number, multiply by 2. If the atomic number is what? Odd number, multiply by 2, then add 1. Please take note, because there are some questions you won't be given mass number. You won't be given mass number. They are, you've been expected to know it. Please take note. In this case, you are not given mass number. Then from here, let's move. Let's move. From here, we have atomic weight ratio. That is, sodium is what? Atomic weight ratio. That means the percentage composition by mass of sodium divided by the what? Atomic mass of what? Or atomic weight of sodium, which is 23. This one, boron, 28.6 divided by atomic weight, which is mass number, 11. Then 10.6, hydrogen is what? 1. Then from here, what we have simplest ratio. Simplest ratio. This one divided by 23 will give you what? 2.6. 2.6. This one divided by 11 will give you what? 222 mega 6 so 2.64 something like that. This one divided by 1 will give you what? 10.6. 10.6. Then what happened? Divide by the what? The smallest. That means we have this one and this one, they are the smaller one. And divided by 2.6, divided by 2.6, divided by what? 2.6. Then from here, this one will give you 1, this one will give you 1, this one will give you 4, 3 point something, 3.9, 3.9 or 4 point, let me see, 4, 2, 4, 8, 9, okay, we give you 4.01, 4.01 or 4.02, 4.01 or 4.02. We give you that. That is, then if you approximate, you have what 4. Then from here, what do we have? That means sodium, empirical formula. Sodium is what? 1. Boron is what? 1. Hydrogen is what? 4. Therefore, we have what? NaBH what? 4. And what do they want you to calculate? The empirical formula, which is what? What option? What option? What option? What option? What option? Option A. Option A. Option A. Please take note. Don't forget, I told you to get mass number is very easy for first 20th element. For first 20th element. For first 20th element, it's easy. It's easy. For first 20th element, it's easy. If the atomic number is even number, multiply by 2. If the atomic number is odd number, multiply by 2, add 1. Please, let's go to the next question. Let's go to the next question. Let's continue with these questions. We have question number 4, solution 4. I'll be fast with my word. Solution now. Solution 4 to question 4. A compound has empirical formula. Empirical formula. A compound has empirical formula of NO2 and a molar mass of 92. They gave us relative molecular mass or molar mass of 92 of the compound, 92 gram per mole. The relative molecular mass of the compound, that is molar mass of NO2, 92 gram per mole. What is the empirical formula of this compound? What is the empirical formula? And we want to calculate the empirical formula. Oh no, I told you molecular formula equal to N times empirical formula. In this case, molecular formula, I have 92, which is the relative molecular mass. Change molecular formula to 92. Then look for N. Let us calculate for N. Empirical formula of that compound is what? NO2. From here, we have 92 equal to N into nitrogen is what? 14. Plus oxygen is what? 16 times 2. That means 32. We have 92 equal to N into we have 46. Then from here, we have what we have? We have N equal to 92 over 46. N equal to what? 2. Therefore, molecular formula equal to what? 2 into NO2. From here, we have molecular formula equal to 2 times 1 here is what? N2. 2 times O2 is what? O4. That is that. Let's go to the next question. The next question says, a compound of XY and CS, HY, and OZ has the following composition by mass. Let's quickly go. We have C. We have elements. We have C. We have H. We have what? O. Then percentage composition. Percentage composition by mass. For C, we have 66.7. For hydrogen, we have 11.1. For oxygen, they say others is oxygen. That means others is what? Oxygen. How do we get oxygen? I told you addition of everything must give you what? 100. Therefore, 66.7 plus 11.1, then take it away from 100. You have what? Percentage composition by mass of what? Oxygen. This added to this, then take it away from 100. You have percentage composition of what? Of oxygen. The percentage composition of oxygen is what? 22.2%. Take note, percent. Then what happened again? The next thing is what? Atomic weight ratio. Atomic weight ratio. You have 66.7. divided by the mass number of carbon 12, 11.1 divided by what? 1, then 22.7 divided by what? 16. What do we have? We have this one will give you 66.7 divided by 12 will give you, we have 5.56. We have 5.56. Yeah, we have 5.56. 5.56. This one will give you 11.1. This one divided by this will give you 1.39. Now 1.39. We give you 1.39. 1.39 or 1.4. 1.39 or 1.4. Okay, then 1.4. Divided by the smallest. Which one is the smallest? This 1.4, 1.4, 1.4. What are we going to have if you divide by 1.4? This one will give you, 1.4 you have 8. This one give you 1. This one give you 2. Yeah, it should be 2. 3.9. It should be okay. 5. Okay, 4. You have 6. 1. 5. Okay. You have 4. You have 4. You have 4. You have 4. Then from here, we have carbon, empirical formula. We have empirical formula equal to carbon. We have 4. Hydrogen, we have what? 8. Oxygen, you have what? 1. Then the question says, what is the molecular formula? What is the molecular formula? When what molecular mass is given as this? And we know that molecular formula equal to what? N times empirical formula. Molecular formula is given as what? 72 equal to N. This one we have C4H8O. Therefore, 72 equal to N into, we have 12 times 4 plus 1 times 8 plus 16. Don't forget, carbon is 12. Hydrogen is what? 1. 1 times 8. Oxygen is 16. 12 times, this one give you 48. 48 plus this. 48 plus this, we have 50. Okay, you have 72. Everything will give you 72. From here, you have 72 equal to N into 72. Divide both sides by 72. By 72, you have N equal to what? 1. N equal to 1. Therefore, in this case, what happened? Since N equal to 1, empirical formula is the same thing as what? Molecular formula. I told you that. Since N equal to 1, empirical formula is the same thing as molecular formula. Empirical formula is the same as what? Molecular formula. Since you have N to be equal to 1, since N equal to 1, you have molecular formula equal to what? Empirical formula. Since N equal to 1, therefore the molecular formula equal to C what? For H8O. That's your answer. Let's go to the last one for today. The last question for today in this video. For today. The last question. We have an organic compound X. An organic compound X. You can pause the video and write, because an organic compound X contain 40% carbon. That means contain 40% carbon. We have oxygen. Let me take hydrogen first. Hydrogen, and we have what? Oxygen. We have elements, as usual. Percentage composition by mass. Carbon is what? 40. Hydrogen is what? 67. Oxygen is 53.3%. What do we have? Atomic weight ratio. Atomic weight ratio. There are 40, carbon is 12, 66% over man, 53.3 over 16. Mass number of oxygen is 16, mass number of hydrogen is 1, mass number of carbon is 12. Take note of that. Take note of that. Take note of that. Sorry, let me take my water. Take note of that. Okay, from here, this is 16. From here, what do we have? We have 40 divided by 12. We give you 3 here, 6, 3, remainder 4, and 4. We give you 3.33. That means you have 12 times 3, we have 36. Take it away, we have 40, also 12, we have 3.33. 3.33. This one will give you a 6.7. This one will give you 53 divided by 53.3 divided by 16 times 3, 8, 1, 4. Take it away, you have 3.33 something. 3. Then from here, simplest ratio. Find the simplest ratio. That is divided by the smaller one. 0.33, 0.33, 0.33. This one will give you 1. This one will give you 2. This one will give you 1. Now this empirical formula equal to what? Carbon 1, hydrogen 1, 2, oxygen 1. That's empirical formula. But the question says, calculate the calculated empirical formula. Yeah. The second question, calculate molecular formula. The vapor density is given as what? Of the compound is given as 30. When the vapor density is given as what? 30. When the vapor density is given as 30. In this case, we are not given relative molecular mass. What is the formula that relates to our molecular mass and what? Vapor density. Molecular mass equal to 2 times vapor density. Take note of this. Molecular mass of a compound equal to what? Twice vapor what? Density. Therefore, molecular mass, that is relative molecular mass. Molecular mass equal to what? 2 times what is vapor density? 30. Therefore, we have molecular mass, which is 60. But they want to calculate molecular formula. You have molecular formula equal to what? N times empirical formula. From here, we have molecular formula equal to N. Empirical formula is what? CH2O. Therefore, let us change molecular mass. Change molecular formula to molecular mass. We have 60 equal to N, so that we can calculate our N. Carbon is what? 12 plus hydrogen 1 times 2, 2 plus 16. This one gives you what? 14. 14 plus 16 gives you what? 30. From here, what do we have? From here, what do we have? We have, let me rub it off. We have 60 equal to N into 30. Divide both sides by what? 30 over 30. Cancel, we have what? N equal to what? 2. Therefore, N equal to what? 2. From here, molecular formula equal to what? 2 times what? Empirical formula. Then, molecular formula equal to 2 times C1 will give you C2. 2 times 2, H4. 2 times 1 will give you that. Take note of that. Please, in the next video, we shall look at what? Combustion analysis. It's a special case for JUPEB students. Combustion analysis. to use combustion analysis to determine what empirical formula is a must that JUPEB student must watch. It's a must because you see it, you have so many questions from your past question from 2015 to 2024. Question has been coming out on what combustion analysis, how to determine empirical formula and molecular formula from combustion analysis. It's a must. It's a must. It will be the next video, which will be the third video. Please subscribe to this YouTube channel. Press the subscribe button. Like it, comment positively on it. Please share it with your friend. For physical classes and online classes, you can call us. We see a WhatsApp link. You can press punch. I like using punch. Punch the WhatsApp link so that you can get into the group and you can call any one of the two admin in the group for any word assistant, physical classes, and word online classes. The only assistance we cannot give is that we can't give you money. That's the only assistance we can't give you money. But any other assistance that is based on what academic support, we are ready to give you. We are ready to give you. Please, may God be with you. My name is JAMB.